Students, in this lesson we are going to learn how to calculate the arguments in different quadrants. In our previous lesson, we saw how to calculate the argument in quadrant 1 using the formula theta equals to arctan b over a, and in the first quadrant, which is between 0 degrees and 90 degrees, my theta or my angle is always going to be less than 90. So my angle this side will always be less than 90 degrees, and we take it as it is. But now when we go to quadrant number 2, if this is 90, I have here 180 degrees. If now I am in quadrant 2, then I draw my point. I draw my complex number like this. My argument must still be from the positive axis of from my real axis on the positive side. So it must that here will be, this will be my argument, my theta. But what I am going to get will not be the theta. If I calculate using the arctan b over a, I will not get a number between 90 degrees and 180 degrees. I am going to get an acute angle. The angle I'm getting in magnitude is this one. So if I use arctan b over a, I'm going to get this angle. I do not want this angle. I want this one. Let's refer to this angle as the reference angle. I want theta. So to get theta, it's not going to be the reference angle, as I said. It's going to be 180 degrees minus the reference angle, which is this, gives me this one. So our ref angle is calculated by arctan b over a. So the formula is actually theta will be equals to 180 degrees minus arctan b over a. If I go to quadrant number 3, the same thing happens. Now, there is my vector for my complex number. My argument must start from the positive side of the real axis. So my argument, my angle will be this. See? Way bigger than 90, between 180 degrees and 270. But if I again calculate arctan b over a, I am going to get just this piece. The angle I'm going to get in magnitude is going to equal just this piece. I don't want just this piece, which I will refer to as my ref angle. Goodness, apologies for that. I will refer to as my ref angle again. I hope the color you can see. Apologies. This will be my ref angle. So it's this angle, this one. I don't just want this angle. I want from 0 going to the arm. So what I'm going to get is that theta is going to be 180 degrees plus 180 is this part plus the one I'm getting on the calculator. So plus the ref angle. So it's 180 degrees. The ref angle is arctan B over A. If I go to quadrant number 4, let me change my color pen. If I'm now in this quadrant, I go from 0. Let me draw my arm again. So if I have my complex number, my arm will come out like this. Right? We've seen it quite a few times now. We know how it works. Now, so the angle now is in quadrant number 4, meaning it's between 270 and 360. The angle must be between 270 and 360. But now when I look at it, if I calculate arctan B over A, what I'm going to get is this part. Right? Or in magnitude, it's going to be this part. In size, it's going to be the same as this part. Right? But I do not want this part. I actually want this one. So what's that? It's actually 360 minus this, which I will refer again to as my ref angle. So the angle I want, my theta, is this. All right. So it's what? 360 minus the ref angle. So theta equals to 360 degrees minus the reference angle, which is 360 degrees plus arctan. Excuse me, not plus, because I don't want this angle. So I'm trying to, from the 360, I am taking out this part. So it's going to be a minus. Apologies for that. Minus B over A. All right. Let's go straight into examples and see how this works. We have a few examples that we are going to do. We are going to, in each case, we are going to be calculating them. We are going to be calculating the modulus, the argument in every single case. So if I'm looking at this, my Argand diagram, make it tidy. All right. It's fine. My Argand diagram is going to be 2 units left, 1, 2, 5 units up. Okay, I have to take this down a bit. All right, apologies. So it's going to be 2 units left, 1, 2, 5 units up, 1, 2, 3, 4, 5. So it's going to be in quadrant number 2. Right. So I am looking for theta, which is this thing. How do I get it? I will go theta equals to, I'm in quadrant 2. So what do I have? 1 theta equals to 180 degrees plus arctan B over A. All right, so I'm going to have 180 degrees What did I say? Plus. I'm so sorry. So it's 180 degrees minus this part. So it's a minus. Minus arctan B over A. So it's 180 degrees minus arctan. By the way, when you do this, you can ignore the signs of the numbers because the formula takes care of them. So I'm going to have my B is 5 and my A is 2. So it's 180 minus arctan 5 over 2. That gives me 111,801 degrees, which makes sense. My theta is between 90 and 180. So it's 111. Does make sense. All right. So that's how you do it. Going on to the second example. All right, I'm still with you. Now I'm looking at minus 2i minus 4i. First and foremost, it's not in proper rectangular form because the imaginary number comes before the real number. I must first put it nicely. So I'm going to have minus 4 minus 2i. Then I can see this is my A and this is my B. If I am to draw it on an Argand diagram, it's going to be minus 4 to the left, minus 2 down. So there it is. In quadrant number 3, I want this theta, where we agreed that our theta equals to 180 degrees plus arctan B over A. So I'm gonna have my theta here equals to 180 degrees minus arctan. My B is 2 and my A is 4. As I said, ignore the signs because the formula takes care of the signs. All right, let's do that and find it quickly. It's a plus. Goodness, I don't know where my mind is at today, but I mentioned nicely here. It's 180 plus. So it's plus 180 plus arctan 2 over 4. That gives me 206,565 degrees. Again, it makes sense because the angle is between 180 and 270. So 206 makes perfect sense. Okay, going forward to the next one, number 3. There is our third example. All right, z equals to 6 minus 9i over 3. Again, it's not in standard form. So our first job is to write it in standard form. We are going to do that. We are going to write it in standard form first. So I'm gonna distribute the denominator. I am going to have z equals to 6 over 3 minus 9i over 3, which comes to 2 minus 3i in standard form or rectangular form. Then when I go to my Argand diagram, I'm going to have 2 to the right, 3 down. So my arm is going to be in quadrant number 4, where we have theta equals to 360 degrees minus arctan B over A. All right. So I'm going to have theta, this is my theta, as 360 degrees minus arctan. My B is 3, my A is 2. And that gives me an answer of 303,690 degrees, which makes sense again. My angle must be between 270 and 360, making 303,690 make perfect sense. All right, the last one I have there is Z equals to 5i. If I am going to do that, if I'm going to draw the Argand diagram for that, I am going to have my real is 0, so there's nothing here. My imaginary is 5, so I'm gonna have 1, 2, 3, 4, 5, just a 5 there. So my area is going to be straight on the axis. All right, if you can look at it, it's directly at 90 degrees. So my angle is like this, directly at 90 degrees. So yeah, in this case, I can simply say my theta equals to a perfect 90 degrees. All right, students, that's it. Hope you're keeping up. See you next lesson.